In this short presentation, I'm going to present the work entitled Saturation Transfer Difference NMR as a useful tool for the characterization of multimeric pyrrolidine iminosugar binding to JH1 β-GLUCOSIDASES. Iminosugars are carbohydrate mimics that constitute the most important family of glucosidase inhibitors. Among them, monocyclic iminosugars, especially piperidines, have been widely studied in this field, being the pyrrolidine analogues less studied. The display of these molecules in a multivalent fashion can afford better inhibitors in terms of potency and selectivity. The multivalent effect can be quantified using the parameter RPN, defined as the relative inhibition potency per monomeric unit. The elucidation of the chemical basis accounting for the interaction of inhibitors of glucosidases of therapeutic interest is the key aspect for the design of selective inhibitors. In this sense, saturation transfer difference NMR, abbreviated as STD-NMR, can be a useful tool to unveil the detailed characterization of ligand binding in the enzyme inhibitors complexes in solution. In this work, we present the synthesis of a set of multimeric pyrrolidine iminosugars prepared by copper-catalyzed acid alkyne cycloaddition between a family of alkyne scaffolds and two pyrrolidine acids. These scaffolds have been easily prepared from commercially available materials in few reaction steps. The pyrrolidine acids have as precursor the acid 7, which has been prepared from the mannose following the procedure previously reported by our group. Bacterial enzymes are in general easy to manipulate and may serve as models to analyze structural aspects related to homologous human proteins. In this sense, the multimeric derivatives have been evaluated towards the GH1 β-glucosidases A and B isolated from Penibacillus polymixa bacteria, BGLA and BGLB from now on. The best results have been obtained for the multimers containing an aromatic moiety in the structure, being inhibitors of BGLA in the low micromolar range. None of the compounds have shown inhibition towards BGLB at 0.1 millimolar despite the high homology between both enzymes. The enzyme inhibitor complexes between BGLA and the trimer and hexamer derivatives of the aromatic acid 6 have been studied by STD-NMR. In solution, the binding of both multimers to BGLA involves contacts with the protein binding pocket all along the whole structure of the ligands, as all ligand protons show significant saturation transfer from the protein. Besides, the STD-NMR experiments confirm the important contribution of the aromatic moiety to the inhibition. Thank you for your kind attention.